Hey guys, Big Dave, time for our Unit 2 review. I'll go through the study guide and the essay question with you. Remember, when you do these, type everything, type up the vocabulary, words and terms, type the questions and the answers on the study guide, and then of course type up the essay question also. So, beautiful day in Morro Bay. Got the ocean behind me, nice clouds in the sky also, right? The lower stratus level is starting to break up. All good stuff. So let's do this. So know how to do relative humidity problems. So you had an exercise on relative humidity. Just maybe write down the formula and how you did a problem. Orographic uplift problems, you did that on the last question on the relative humidity assignments. Maybe you could draw a little something for me or a diagram. That would be fine. What are the three ways to make the air rise, expand, and cool? Number one is convectional uplift, when the ground gets really warm, possibly, and the air above it gets warm, and the air begins to rise. Number two is converging uplift, when two air masses come together and the air is forced to rise. Number three is orographic uplift, like you did on question, I think it was 3 on the relative humidity problem, where the air is forced into a mountain and it has to rise. Remember, to make it rain, you have to make the air go up. As it goes up, it cools off, first at that dry adiabatic lapse rate, and then if condensation starts in clouds, then it cools off at the wet adiabatic lapse rate, and that's when you get condensation onto little particles in the air, and you can get clouds and maybe rain or snow. Let's see here. What is the most common type of precipitation? That would be rain. It takes about 1 million little cloud droplets to coalesce together, to come together, to be big enough to form a raindrop. What happens to relative humidity when the difference between the wet bulb temperature and the dry bulb temperature increases or decreases? If the temperature between the wet bulb and the dry bulb is really close, that means the relative humidity is going to be really high. If the temperature between the two bulbs on the device called a sling cyclometer is great, the difference between them great, it means the relative humidity is kind of low. That's a tough question because normally when I do a lecture, I can show you all this stuff. So do the best you can on that one. You will have a question about the conditions that create absolute stability in the atmosphere. That's another really tough question. It's in your textbook. But basically what you want to write down is when you have absolute stability, it means it's not going to rain. It means the environmental lapse rate is a higher number or is greater than the dry adiabatic lapse rate. That means the air is not going to want to rise, basically. That's another really tough one for me to do in an online class, unfortunately. According to the Bergeron process, what grows larger, ice particles or water droplets? Okay. Within clouds in the mid-latitudes where we live, it's very common within the same cloud to have water droplets and ice crystals. And what happens according, to Bergeron, is the ice particles grow bigger while the water droplets go smaller. That's because it's easier for water molecules to escape from a liquid than it is a solid, because they're moving faster in a liquid. So they escape and they attach onto the ice particle, which grows bigger, and then it may fall as a snowflake or may melt on the way down and be a raindrop. Another complicated topic, that Bergeron process. Know the latitudes of all the wind and pressure belts. So on your wind and pressure belt assignment, I had you write down all the latitudes. So write those down on the study guide for me. Okay? Or you can take a photo of the assignment you did if it was done correctly, if you have all the latitudes in there of the wind belts and pressure belts. What is standard atmospheric pressure at sea level in inches and centimeters of mercury, pounds per square inch, and millibars? Okay, it's 29.92 inches of mercury, or it's 76 centimeters of mercury, or standard atmospheric pressure at sea level, like right behind me on a normal day, would be 14.7 pounds per square inch, or 1013.2 on the millibar scale. When do you switch to the wet adiabatic lapse rate? That's when the air is rising and condensation begins. In other words, the water vapor becomes a liquid. It goes from a gas to a liquid. So you switch to the wet adiabatic lapse rate when the air is rising and condensing. Are anticyclones conducive to heavy precipitation? The answer is no. Anticyclones are high-pressure systems, and when you have high pressure, it's generally not going to rain or snow. What causes trade winds? It's the pressure gradient. Again, refer back to that wind and pressure belt assignment you had. It's the pressure gradient between the subtropical high and the equatorial low. Winds blow from high to low. So what causes the trade winds? The pressure gradient between the subtropical high, the equatorial low, with winds being deflected to the right in the northern hemisphere, the left in the southern hemisphere, due to the Coriolis effect. Okay, to the right in the northern hemisphere, to the left in the southern hemisphere. Know the characteristics of cyclones and anticyclones in each hemisphere. Okay, with cyclones, that's a low-pressure system. The air is converging at the surface and rising. Converging and rising, and as the air does that, in the northern hemisphere, there is going to be a counterclockwise rotation. In the southern hemisphere, a clockwise rotation. So with cyclones, the air converges and rises. The motion of the air is counterclockwise in the northern hemisphere, clockwise in the southern hemisphere. That has to do with the Coriolis effect. Anticyclones. Okay, in an anticyclone, the air is subsiding, diverging at the surface. So it comes down and moves out in different directions at the surface. The motion of the air is clockwise in the northern hemisphere, counterclockwise in the southern hemisphere. This again is due to the Coriolis effect. What time of the day would you expect to find maximum and minimum relative humidity? Generally speaking, you have highest relative humidity in the morning. That's when you have dew on the lawn. There's more moisture in the air. Lowest relative humidity is in the afternoon when it's warmer. Warmer holds more moisture. So if the air can hold more moisture and there's not a lot in the air, right, you will have a lower relative humidity. Does the jet stream provide heat exchange in the atmosphere? It does. Jet streams are high altitude winds. Often they go into these long waves, these Rossby waves, and that can bring warm air from equatorial regions north, or it can bring colder air from polar regions further to the south. Can jet streams develop oscillatory patterns? Yes, wave patterns like this. Those are Rossby waves, and it's very common, particularly in the winter and in the summer times. What do isobars connect? Isobars probably, let's see, connect the best bars, right, in the Visalia area. What would that have to be? Let's see. The Blitz, does it still exist downtown? I don't know. The Green Olive, the Pump House. Oh, yeah. Anyways, that's stupid. What do isobars connect? Isobars connect points of equal atmospheric pressure. So leave the part out about the bars. Just Big Dave giving you a little funny, okay? All right, connect points of equal average air pressure. What determines the air's capacity to hold water vapor? Okay, the ability for the air to hold water vapor is determined by temperature. The warmer the air, the more water vapor it can hold. Geostrophic winds are winds that blow with the isobars, parallel to the isobars. And they're created when there's a balance between the pressure gradient and the Coriolis. The pressure gradient force says winds move from where the air is heavier to where it's lighter, from high pressure to low pressure. And the Coriolis again makes winds want to go to the right in the northern hemisphere, to the left in the southern hemisphere. This is a complicated topic, but basically what you're going to write is it's a balance between the pressure gradient and the Coriolis effect. Okay, next page, or I'm turning mine over. What time of the day would you experience the greatest cold air drainage off the mountain slopes? Okay, when I lived in Three Rivers, in the mornings when I would come down, that's when the cold air was seeping down the mountainside and going down into the valley. So it would be early in the morning. Is a radiation fog an indicator of a temperature inversion? The answer to that is yes, definitely, because when you have a temperature inversion, right, it means that it gets warmer as you go up. When we get the Thule fog, the radiation fog in Visalia, it means the air is very cold. Near the surface, it's been cooled below the dew point temperature. The dew point is the temperature at which the air is holding all the moisture that it can. If you cool it below that temperature, condensation occurs, gas to a liquid, and that radiation fog forms. So it's colder near the surface. As you go up, it's warmer. You don't see any fog. The air has not been cooled below the dew point temperature. Is the predictability of cloud seeding well established? No, it is not. We seed the clouds above the Sierra, right, to try to get more precipitation out. They put like condensation or freezing nuclei into the clouds. Airplanes go up, they have these things called burners, and they release these particles, which is supposed to create more precipitation. All right, is the collision coalescence process of precipitation more likely to occur in tropical or polar regions? That's tropical areas where you don't have a lot of ice crystals in the cloud. It's water droplets kind of coming together, coalescing together to go bigger and bigger until they're big enough to fall as a raindrop, so tropical areas. Is a subtropical jet an easterly wind or a westerly wind? The subtropical jet is an easterly wind, meaning, it's a westerly wind, means it comes from the west the majority of the time. That's the jet stream that will bring in storms from the Gulf of Alaska into California, we hope, right, in the wintertime. What are Föhn winds, right? It's a German word. I think it's pronounced sort of like Föhn. Those are winds that are warm and dry that come down the side of a mountain. Yeah, Föhn winds, right? So those are winds like Chinook winds that come off the east side of the Rocky Mountains in Colorado and Alberta and Canada. Those are Santa Ana winds. Right? Those are the winds that LA gets a lot of times in the summer and the fall that are really low in humidity. It can cause fires. Downslope winds, they're called over here in the Central Coast and in Santa Barbara. Sundowner winds, that term is sometimes used also. Okay, so they're warm, dry winds that blow down the side of the mountain. Is the Coriolis effect strongest at the equator or the poles? It would be 0 at the equator and stronger at the poles. There's a formula for it, and it has a sign in it, like a trigonometry, and you plug the latitude into that. If you plug 0 in the equator, the whole equation, as you know, an algebraic equation becomes 0. So you want to say that it is strongest at the poles and weakest at the equator. Do you name wind direction based on where they're coming from or where they're blowing to? You name winds the direction which they're coming from. As I sit here right now, the winds are coming off of the ocean. It's clouding up more too. Great day. Look at the clouds behind me, right? So it's coming off the ocean, coming from the west. So you name the winds, the direction the winds are coming from. What causes a sea breeze? It's the difference in temperature between land and water. Okay, so like Paso Robles right now is going to be probably warming up today. It's going to be warmer than here in Morro Bay. That warm air begins to rise. That's low pressure. Colder air over the water. That's high pressure. Winds blow from high to low. From over the water in this case to the land. From high pressure to low pressure. Okay, so it's a difference in temperature between the land and the water. Dew point is the temperature at which the air is fully saturated. It's the temperature at which it's 100% relative humidity. It's the temperature at which the air is holding all the moisture that it can. Does air pressure increase or decrease with increased elevation? Air pressure decreases the higher up that you go. Are winds deflected to the right or the left in the northern hemisphere? That is to the right. That's the Coriolis effect. Do upper air winds blow at a higher or lower velocity compared to surface winds? Almost always they're going to be blowing at a higher velocity. There's less friction. The winds aren't running into buildings and mountains and forests and things like that at higher elevations. Does the land sea breeze cycle follow a daily pattern? Yes, generally. A lot of times here in Morro Bay in the morning there's an offshore wind. The wind is coming more from the east, but by the afternoon, as inland areas warm up, like Atascadero and Paso Robles, right, low pressure develops and the winds come off of the ocean. So it's more of a daily pattern. What kind of clouds are associated with hail? That would be cumulonimbus clouds. How does advection fog form? Advection fog is a coastal fog. It's the kind of fog we get a lot of here in Morro Bay. That's when warm, moist air is blown over a colder surface. If the air is blown over a colder surface, be it in the ocean or over land, that air is going to cool below the dew point temperature. You get condensation, a gas to a liquid condensation onto little particles over here in sea salt, generally. right? And that's how the fog forms. Advection fog, a coastal fog, a moving, a rolling fog. Would a steep pressure gradient be indicated by closely or widely spaced isobars? When isobars are close together, remember they record areas of equal atmospheric pressure. When they're close together, it means a rapid change of pressure from one location to another. And so that indicates a steep pressure gradient. That indicates strong winds, because winds blow as a result of the difference in air pressure, the difference in the weight of the air. Winds blow from where the air is heavier, high pressure, to where it's lighter, low pressure. You don't have to worry about the two matching sections. The essay question, here you go. So you're going to draw a hypothetical continent, any shape you want, a basketball, a football, whatever you want, and put the latitude lines on. That's very important to me. Those are the lines that go east-west. Okay, that's going to tell me a lot about where you're putting your dry spot. So you want to create a condition that would be really dry. So designate that location with an X, okay? So your continent's going to be surrounded by water, any size you want, any shape you want, latitude lines. Put an X somewhere you think would be dry. Okay, so you can use landforms. So here are your hints. You don't put your X near water. Why? Because water, obviously the air above it's going to have more moisture in it. You want to put it somewhere in the middle of the continent, probably. You don't want to put it in an area of low pressure. Low pressure means stormy, rainy weather. You don't put it at the equator. You don't put it at 60, 65 degrees. Referring back to the assignment you did on atmospheric pressure and winds, don't put it in a low pressure area. If you use mountains, and I would, landforms like mountains, put it on the leeward side. So when you put your latitudes in, be sure you understand where the leeward side of the mountain would be. For example, from 35 to 60 degrees, north and south latitudes, we're in the westerlies. The winds come off of the ocean here. So the dry side, right, of your mountain would be the east side, like the east side of the Sierra Nevada. Because the winds are forced up the west side, you get more orographic precipitation. A lot of moisture squeezed out by the time you get to the leeward side. So again, what you're going to draw a continent, and then you're going to type out a little essay for me. It doesn't have to be more than, definitely not more than a page for this, okay? And tell me why that spot was dry. Again, you're going to tell me I didn't put it near a body of water because there's a lot of moisture in the air around bodies of water. You're going to put it in a high pressure zone if possible, okay? Because high pressure, the air is subsiding, and that's not how you make it rain. You make it rain, the air going up, like at the equator or at 60, 65 degrees in the subpolar lows. On a mountain range, be sure you understand your wind belts. Put it on the leeward side. For us here in California, that is the east side. Okay, I hope that helps you. Do a good job on this, okay? Time for Uncle Dave to jump in the water. Time to go. I'm trying to learn to surf. I'm getting a little better. I still suck, but I'm really trying. All right, guys.